Jumbo. In this session, we look at cost functions. We continue looking at farm theory. Farm is an economic agent, as we learned in our introductory video on microeconomics. And here, we'll be looking at cost functions. The cost function expresses the functional relationship between total costs and factors that determine it. Usually, the factors that would determine the total cost of production, which we shall be denoting as C, are output, and we could denote output as Q or O, and the level of technology T, the prices of factors of production PF, and the fixed factors F. And as such, we can symbolically express the cost function as C is a function of, remember C is total cost, is a function of Q, which is output, T, which is technology, PF, which is prices of factors of production, and then F, which are some fixed factors. In subsequent slides, we shall see that we distinguish costs either as fixed cost or variable cost, but we shall see that. However, it is difficult to show the cost function graphically. Remember, at this stage of introduction to microeconomics, most of what we'll be doing is graphical, and we may not be able to draw a graph that has got all these functions. And as a result, we simplify the cost functions where we make certain assumptions. And one of the major assumptions that we make is that the farm produces only one single product, which is the same. All farms produces that single homogeneous product. Homogeneous will mean the same, which we shall denote as Q, but this is the help of certain factors of production. All right. We find that some of these factors are employed in fixed quantities. It doesn't matter what level of output the farm would produce in the short run. We assume that those factors are fixed. You know, when we talk of certain factors being employed in fixed quantities, you can imagine a situation of a classroom. If we have 100 students, then we'll fit a certain fixed class. All right? And we find that in this duration that we have some factors which are fixed. It relate to the short-run situation. So the short-run situation of a farm is that farm that some factors of production are fixed, and hence we have fixed costs. Those costs which are not fixed are known as variable costs. Okay, those costs that are not fixed are known as variable costs, and they vary with level of output. The other assumption that we'll have to make is that there are no changes in technology. So when we are looking at the cost function in the short run, we make certain assumptions. And those assumptions are, one, there's a single homogeneous good which is being produced, and we shall denote it as Q. The other assumption is that it is a short-run situation, and as such, there are some fixed costs. 3, those factors that are not fixed are variable costs. And 4, there are no changes in technology. Those are the assumptions that we make for a farm to be producing in the short run. The other, not really an assumption, but would say that if a farm would want to improve or to increase its output, it would have to adjust the amount of variable factors that is using. So that for a given output Q, we obtain it, or of the good Q is obtained at the minimum cost, which is C. So for a farm, remember the other video we said some of the goals of the farm is actually cost minimization. So every production that we make, the farm is assumed that it wants to minimize costs. And in such a case, we express the cost function as being C is a function of the various outputs, which we've said will restrict to one of a farm. We may want to discuss this cost-output relationship in both the traditional approach and the modern approach of short-run and long-run cost analysis. Remember I said in the short run, that's the period in which some of the costs are fixed. But in the long run, we realize that all costs are actually variable. We shall later explain the distinction between, which is very important, the distinction between variable cost and fixed costs. Let's start with the traditional theory of costs. In the traditional analysis of costs, the behavior of cost curves in the short run and in the long run is made, and we arrive at the conclusion that both short run and long run curves are U-shaped. Very important. Both short run and long run curves are U-shaped. However, the long run curves are flatter than the short run curves. We shall see that distinction shortly. That slide, we've already discussed it. But let's start with the farm's short-run cost curves. The short-run period is defined as that period where the farm cannot change its plant, its equipment, and the scale of organization. The scale of organization is its size. If the farm would want to meet increased demand, if the farm would want to increase its output, it can only hire more labor and raw materials or by asking the existing labor force to work overtime. But it cannot change its size. All right? For instance, the university may not expand. We can only have various classes and staff working overtime. Now, with the scale of the organization being fixed, with the size of organization being fixed, that is in the short-run situation, we define the costs that we are trying to minimize as total fixed costs and total variable costs. And therefore, total costs is denoted as total fixed cost plus total variable costs. What are total costs, which we shall be abbreviating as TC? These are the expenses that a farm incurs in producing a given quantity of a commodity. Remember we said the total cost is made up of both the fixed cost and the variable cost. And this cost would include expenses such as rent, wages, interest, taxes, and so forth. Now, we said we divide this total cost either into total fixed cost or total variable costs. We abbreviate total fixed cost as TFC. Now, what are total fixed costs? These are costs of production that do not change with changes in output. They remain fixed irrespective of the output level. If the output level is 0, those costs will have to remain. If it's 100, they remain the same. As such, they are independent of output. And as I stated, the farm will even incur them even when the farm stop production temporarily. For instance, when schools and universities were closed because of COVID, even though no learning was taking place, you find that the staff still had to be paid. All right. So you find that such costs would include things like payment for renting land and buildings, interests, and so forth there. And sometimes we refer to this cost as overhead costs. Then we have the total variable costs. And the total variable costs are those costs of production that change directly with output. As output increases, variable cost increases. As output decreases, variable cost decreases. And they include expenses of raw material, power, water, etc. And sometimes we refer to them as direct costs. Let's now turn our attention to short-run average cost curves. In the short-run analysis of a farm, we find that average costs are more important than total costs. The unit of output that a farm produces may not cost the same, even though they are sold at the same prices. And it is therefore important that a farm is able to know what the average cost is. This short-run average cost of the farm would include average fixed costs, average variable costs, and average total cost, and I may want to include the marginal cost, which we say it's a very fundamental cost that we use to determine the exact level of output. And very important, we define marginal cost as the additional to total cost if we produced an additional unit of output. And there are two ways that we can determine marginal cost, which we abbreviate as MC. It is the change in total cost over change in output, or depending on the information that we've been given, marginal cost can be taken as the derivative of total cost in respect to output, as the formula to use depends on the information that we've been given. This relationship between total cost, variable cost, and fixed cost is presented in a table that I'm going to show you shortly, where we find that in one column, we have different levels of output from 0 to 10 units. Let me show you the table. We have the total output from 0 to 10. We could go back. Actually, let me explain everything, then we go. Then in column 2, we have total fixed cost, which remains the same as 300 at all levels of output. We find that the fixed cost is 300 all through. It doesn't matter whether total output is 0, total fixed cost remains at 300, or whether they are 10, the total fixed cost would remain the same. And then we have column 3 that shows total variable cost, which are 0 when output is nothing, and they continue to increase as output increases. Notice about our total variable cost. When output is 0, it is 0. But they increase as output increases from 0 all the way to 2000. Then we can move on. And we find that in the short run, though I'll come back again, these variable costs rise quickly, then slowly down as the farm enjoys economies of scale. And I'm going to encourage you to go and find the distinction between economies of scale and diseconomies of scale. So we are saying the variable cost initially rise quickly and then slow down as the firm enjoys large scale production and with further increase of production. But as output increases, diseconomies of scale set in and the variable cost starts rising rapidly. Column 4 relates to total costs of column 2 and 3. That is total cost. This should be an equal sign. So take note of this. This should have been an equal sign is equal to total fixed cost plus total variable cost. And we shall note that this total cost vary with total variable cost when the firm starts production. We have a table. I've got some figures which have been put in, and I'll be asking you to input the other values at your time. Normally, you are given the first 3 columns. Then you are supposed to compute the rest. The total costs, as you shall see, I'll explain in subsequent slides, or we've already stated it, is total fixed cost plus total variable cost. So we find that when output is 0, total cost is 300 fixed cost plus 0, which is total variable cost when output is 0, 300. Then we do the same when output is 1. 300 plus 300 is equal to 600. Then when output is 2, 300 plus 400, 700, and so forth. And you get your total cost. Then I've got average cost. I've only inputted some, not all. We have the average fixed costs being 300. And how do we get average fixed costs? It's total fixed cost divided by output. Now, when you divide any number by 0, the answer that you get should actually be infinity. Infinity is a very big number, but the largest that this average fixed cost can be is 300. Then 600 divided by 1, that would be 600. 700 divided by level of output, 350. 750 divided by 3, 250, and so forth. Then the average variable cost, you divide the total variable costs with output. You divide the total variable cost with output. So for first one, I have not filled in any. It will be 0 divided by 0, which obviously will be 0. The next one will be 300 divided by 1, which should be 300. Then would have 400 divided by 2, 200. 450 divided by 3, 150, and so forth. Then average total costs, you simply either you add average fixed cost with average variable cost, or you simply divide total cost with output level. Okay, so if you were to add this, we said is 0, so this would be 300 plus 0 will be 300, and so forth. Then marginal cost, very important. How do we compute marginal cost? With the information that we have here, marginal cost can only be computed as change in total costs, this, over change in output. Now, we wouldn't have anything in the first instance, because you see it was 0 and before 0 there was nothing. But what of when output was 1? What is marginal cost? And marginal cost, we said, is change in total costs, which is basically 600 minus 300 over change in output, which is 1 minus 0. And therefore, what we have is 600 minus 300, that is 300, divided by 1 minus 0, that is 1. So this would be 300. Then 700 minus 600, which is 100. Then 2 minus 1, which is 1. 100 divided by 1 would be 100. The other is 750 minus 700, which is 3 minus 2. So 50 minus 750 minus 700 is 50. 3 minus 2 is 1. 50 divided by 1 is 50. And you do the same. When you do the same and you plot those curves, because I'll ask you to plot them, you'll find that the average fixed cost curve decreases continuously without touching any of the axes. It's continuously declining. Because remember, we said fixed costs do not change with level of output. And as output increases, then the average fixed cost will go down over and over again. For variable costs, average variable cost, we initially said it increases rapidly because of the application of economies of scale, but beyond a certain point, it starts going up because of the applications of these economies of scale, and hence it is U-shaped. The average total cost curve is also U-shaped because you find that the cost also declines rapidly and then starts going up. Reaches a minimum, then starts increasing. I want you to note that marginal cost curve is also U-shaped. But when it is equal to either average variable cost or average total cost, either of those two curves are at their minimum point. The average variable cost curve is at its minimum when it's being cut by the marginal cost curve from the left. And it is the same case for average total cost curve. It is being cut by the marginal cost curve at its minimum. And that's have got a very important lessons in economics, and we shall see them shortly. Now, we explain these curves. How do they arise? How do we compute them? We start with average fixed costs. We said we obtain average fixed cost by dividing the total fixed cost with output. Okay? And like I've mentioned, the average cost curve slopes downward throughout its length. And as output increases, the total fixed costs are spread over more and more units, and therefore average fixed cost becomes less and less. However, when output is very large, average costs approaches zero, but they are never zero. Average fixed cost rather approaches zero, but they are never zero. What about short-run average cost curves? We said the short-run average variable cost is obtained by the quotient of the total variable cost over output. We divide the total variable cost by the number of units produced. And we find the variable cost will generally fall as output increases from zero to normal capacity. This is due to occurrence of increasing returns to scale or economies of scale. But beyond the normal capacity, average cost will rise steeply because of the operation of diminishing returns. Let's go back to this curve. This curve, when it is minimum, when cost stops declining and they start increasing, then that's the normal capacity of the farm. That's what we are being told. And it is the same, though I've not indicated here, about the short-run average total cost curve. Let's look at the long-run cost functions. It is important to note that in the long run, we have no fixed factors of production, and hence there's no fixed costs. In the long run, we have no fixed costs. In the short run, we have fixed costs. The farm can change its size or scale of plant and employ more or less inputs. We find that in the long run, all factors are variable, and hence all costs are variable. In the long run, The average total cost curve, or the LAC curve, shows the minimum average cost of producing various levels of output from all possible short-run average costs curves. And we derive the long-run average cost curves from several short-run average cost curves. We look at the average cost curve as a series of short-run alternative situations into any one of which the firm can move. Each short-run average cost curve will represent a plant of a particular size which is suitable for a particular range of output. The firm thus will make use of various plants up to that level where the short-run average cost curve fall by producing various output. This is the situation. We've got several short-run situations, SAC1, SAC2, and SAC3. We find that a firm will produce up to a certain level until cost starts falling. And when cost starts going down, the firm will move to the next. All right? And each curve will represent a firm of a particular size. As you notice, the same explanation that we've got there. And in the long run, what happens? We've got this flatter long run average cost curve, and you could notice the long run marginal cost curve. But the most important thing to note is that the long run average cost curve is flatter than the short run average cost curve. That's the important thing to notice. That's the end of that presentation. Thank you.